Okay, in this video, we're actually going to take a look at 7F, which is true bearings. So 7G we will do later. This is just about 7F. Okay, so true bearings. True bearings are describing the direction from one object to another, and it's always going to be comparing it to the true north direction. You have to remember that it is always being measured clockwise. So that's important. And then it is always, always, always written with three digits. So, for example, if it's a 15-degree um, true north direction, then you would write it as 015 because it has to be or digits, excuse me. Um, okay, so let's take a look at an example. So, actually, just so you guys have an idea, let's look at this first. So from A to B, the bearing of B from A, if you look at A in this diagram, true north would be straight up. And so that 48-degree angle is going to be your bearing of B from A. Um, so that would be your clockwise order to get down to B. Okay, so it says when Samantha goes jogging, she finishes 2 kilometers south and 3 kilometers west of where she started. So if we think about this as her start point, that is her start. She goes 2 kilometers south and 3 kilometers west. And that's where she finishes. Okay, and it says find Samantha's bearing from her starting point. So if we think about this, this is going to be my bearing north. And so it always has to go clockwise. So this is what we are finding, that entire angle there. And we know a straight line gives us 180 degrees. So I know this is 180. What I don't know is this interior part. But I know I have a right angle right there. And so we can use trig to find that theta. So this is my opposite and this is my adjacent, which is tangent. So we have the tangent of theta is equal to 3 over 2. And then we need to do our inverse tangent here on both sides so that that cancels. And so we end up with theta being, if we go 3 sig fig, 56.3 degrees. So this angle in here is 56.3, but then we also have this 180 degrees right here. So we have to add 180 plus our 56.3, and her bearing is going to be 236.3 degrees. And there would be your bearing. Let's take a look at another one. So Julia is swimming in the ocean. A current takes her 200 meters north and 100 meters west of where she started. So she's going 200 meters north and then 100 meters west, which I know that that's east technically. You could go the other way. I'll erase it so it makes more sense for you guys. Let's go. So she's going north and west. So north 200, that's a right angle, and then west 100. And how far is she from where she started? So isn't this where she starts and finishes? So this is what we are finding. So this is a right triangle, which means we can use Pythagorean theorem. So you have 200 squared plus 100 squared is equal to x squared. When you add those two together, you get 50,000 is equal to x squared. And so then you got to square root both sides. And so she is the square root of 50,000. What do we got? Meters away from where she started. There is our answer for that question. So then the next part says to find Julia's bearings from her starting point. So if we think about her triangle here, and this is always just the direction I draw my triangles. So here's where she starts and here's where she finishes. So this is going to be my 200. This is going to be my 100. And we want to find her bearing from her starting point. So again, true north is going to be that direction, and we have to go clockwise. So that's the part that I'm finding. And if you think about, I'm going to change my color here. If you think about the coordinate plane like this as the coordinate plane, when I move that, so if I go from here to here, that's 270 degrees. So I want